Okay, so in this section, we will discuss about how to describe and explore the data and finally compare the data. Okay, so we start with the measures of center. So in this section, we're going to explore how to measure center of the data. Center means think about this. You would like to find out average household income in a city, then that means that average stands for center of the data, and there are different ways to measure that center. Okay, so our goal is to talk about how to measure the center, especially we use mean and median to represent center. Okay, so start with the mean. A measure of center is a value at the center or middle of the data set. So that value could be mean, could be median, could be mode, could be mid range. Okay, so let's start with the mean. The mean, which means actually arithmetic mean of a set of data, is the measure of center found by adding all of the data values and dividing the total by the number of data values. So this is how we find the mean. If you have given a data, add all of them and divide that data, that sum, by a total number of data. Okay, so we often use average for mean, but that's not the word we prefer to use because the average term is not used by a statistician. So this average doesn't always mean mean. It could be something else like median, or could be mode, or could be mid range. So you have to be mindful that average always does not stand for mean for us. Okay, so if we important properties of the mean, sample means drawn from the sample population tend to vary less than other measures of center. Remember, there are other measures of center like median or mode or mid range, but if you take sample mean from the sample population, then the mean varies very less. But one of the disadvantages of the mean is sometimes the outlier value could be can change the mean in a huge manner. For example, let's say there are 5 family with and our goal is to find out the average household income. Okay, and this is a sample we are taking, and let's say for the first family the household income is 20k, 30k, 40k, 50k. And now for this 4 family, the the average would be addition of this number divided by 4, which is almost 35k. But let's say there is a family which makes 500k. So this number is an outlier. Now if you try to find out the mean of this 5 family, then you have to add all this number and divide by 5, which is if you add 550, 590, 620, 640k divided by 5, which is 128, 128k. That's the mean of this household income for this 5 family, but that does not represent actually the average value. So in this case, because of this outlier, because of this huge number, the mean is not measure of center. Okay, there is a one word called resistant. A statistic is resistant if the presence of extreme value does not cause it to change very much. So here the presence of this outlier cause change very much. That means mean, using the following definition, we say that mean is not resistant because of this outlier. Mean is not resistant. Resistant means it's that outlier should not affect that much in that measure of center. Remember, one more time, measure of center means a number which we are planning to use to represent a center of the data. Okay, so this is how we use formula for finding the mean. We try to add all the data and divide by total number of data. This is the notation we use. This notation is also called sigma, which means sum of all the data. This x is the data. So if the data are sampled from a population, the mean is denoted by x bar. This x bar means it's a mean but for the sample. And there is a different notation called mu. This is also mean, but that's for population. So sigma, this is the first one, notation is sigma, that represents the sum of the data. That is the notation for the sum. X means the data value variable. N is the number of data value in sample, and capital N is the number of data value in population. So if we are playing with the sample, this is the formula we are going to use for finding the mean. And if we have given population, then this is the formula we're going to use for finding the mean. Both of them represents mean, but one is with the sample and one is for entire population. One example, data set. So let's say there is a data set. Don't worry about this number. These are the data sets you have given. 1 2 3 4 5 6 7 8 9 10 11 datas. So data set, instead of 33, think about data set given here. Disney World wait times includes wait time in minutes for 6 popular rides. So these are the time for the 6 popular rides. Find the mean of the first 11 wait times for Space Mountain at 10 a.m. So for finding the mean, you just have to add these numbers and divide by total number of data. So if you do that, this is the number we're going to get, which is 39.1 minute. Okay, the mean of the wait time for Space Mountain is 39.1 minutes. So that's the mean. There is another measure of center that's called median. Median means it's the middle value of the data, and depending on either you have odd number of data or even number of data, there is a way to find the middle number. And the good thing about this median is it's a resistant measure of center, meaning the outlier or any outliers would not affect that much for the median, like it did for mean here. This outlier, because of this 500k, the mean is very, very high. Mean is not resistant, though median is resistant. Okay, so for finding the median, we try to sort the data either in increasing or decreasing order and find out the middle value. Now, depending on how many data you have, if you have odd number of data, you can always exactly find the middle number. If the number of data value is odd, the median is the number located in the exact middle of the sorted list. So you have to sort the data first and then find out the exact middle number. If there are even number of data, the median is found by computing the mean of the 2 middle numbers in the sorted list. So for example, let's say this is the same example. First of all, for finding the middle, we need to count how many data are there. There are 11s, and then after that we have to sort it. So here in this case, we are sorting it from lower to higher, and because there are 11 number of data, the middle number is 35. 11, 5 to the left, 5 to the right, so this is the middle number. Because the number of data value is an odd number, the median is the data value that is exactly middle of the sorted list, which is 35 minutes. Remember, 35 is the median for this data, whereas 39.1 was the mean for the data. So they are different values. Okay. So repeat of the previous example after including the 12th wait time. So now we're adding one more wait time. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 11, now there are 12. So we have to first sort the data And because there are two middle number 1, 2, 3, 4, 5, 6 and 7, these are the two middle number, because to the left of these two number there are 5 datas, to the right of these two number there are 1, 2, 3, 4, 5 datas. So for finding the median of this type of even data set, you have to add these two middle number and divide it by 2. Okay, there is another center of measure that's called mode. Mode means it's the highest greatest repeated value. The mode of the data set is the value that occurs with the greatest frequency. The mode can be found with qualitative data. A data set can have no mode or one mode or multiple modes. So these are the observation. If you have two mode, that means that's called bimodal. If you have more than two modes, that's called multimodal. If you do not have any mode, that's called no mode. I'm going to give you example here. This is the data set. We sorted the data, and after sorting we can see that 30 repeated 2 times, 35 is repeating 3 times, 50 repeating 2 times. So that means 35 is has the highest repeated value. So that means 35 minute is the mode, because it's 3 times. For the 2 mode, let's say these are the data we are playing with. 30 and 50, they are repeating same number of times. So that means there are 2 modes, 30 and 50. No mode, let's say this is another data set. So here nothing is repeating, so that means we don't have anything, no mode in this case. There is another the measure of center, that's called mid-range. For finding the mid-range, we have to sort the data and we have to find this value, add maximum data value plus minimum data value and divide it by 2. That gives you mid-range. Okay, the mid-range is not resistant. It changes because of the outlier, so it's not resistant. Though it's the properties of mid-range, it's very easy to compute. So because of the mid-range, we can say that there are different ways to measure the center. So sometimes we use mid-range incorrectly for the median, but that's not the case. They are totally different value. So let's say this is the data and we would like to find out the mid-range. First of all, we need to sort the data, and after sorting the data we can find the maximum value, which is 75, and minimum value, which is 20. Add them and divide it by 2. That gives us mid-range. While calculating this measure of center, you might have to sometime round off, and these are the rules we can use for rounding. For the mean, median and mid-range, carry one more decimal place than in the original set of data. So one more decimal place than original set of the data. If your data value doesn't have any decimal number, then after calculating mean, median and mid-range, go up to 1 decimal place if your calculation have more than 1 decimal. For the mode, you don't have to do anything. Mode means maximum repetition, so you don't have to round it. Use exact number. Okay, so we can always calculate measure of center from a sample numbers, but we should always think about whether it makes sense to do that. Sometime we can calculate the calculate the number, we can measure the center, but sometimes it doesn't make sense to us. So I'm going to go over some examples where this measure of center doesn't make sense. Okay, so always we have to think about either that makes sense or not, and we also have to think about how we are using samples, our sampling method. So one example, let's say you have the zip codes. This is the data for the zip codes. Zip codes of the Gateway Arc in St. Louis, White House, Air Force Division of the Pentagon, Empire State Building, and Statue of Liberty. So these are the zip codes for 5 different location. But even though you can find the measure of center, you can measure the center, but it doesn't make sense because this is just these are just zip codes. The zip codes doesn't measure or count anything. The number are just labels for geographical location. Another example, let's say there is a ranking system of different university in this case, in our example, Medical School of Harvard, John Hopkins, Newark University, Stanford University, and Duke University. And these are the ranking. In this case, in this ranking, finding the measure of center, it doesn't make sense because you cannot use that information. The ranks reflects an ordering, but they do not measure or count anything. More example, these are the jersey number, and it doesn't make sense to find the measure of center. And these are the compensation for top 5 annual compensation. So it's for the top earner, so it's not actually measure of center. Okay, and here is another example. The 50 mean ages computed from the means in each of the 50 states. If you calculate the mean of those 50 states, 50 values, the result is not the mean age of the people in the entire United States. So first of all, we take the mean of each of the states, and now we're taking the mean of the mean, which is not going to reflect the mean of entire United States. So it doesn't make sense to calculate the measure the center here. Okay, sometime we also have to calculate from the frequency distribution. If you remember from previous sections, we have the frequency distribution. To calculate the mean from frequency distribution, we can use this formula. We can always multiply the frequency by midpoint of the data set we have given and divide by the total frequency. I'm going to give you one example here. This is the class interval, and this is the frequency. This is the mid value of this interval, like 0 to 14 mid value is 7, 15 to 29 mid value is 22, 30 to 44 mid value is 37. To calculate the average, first of all, multiply these two, that gives you frequency times mid value. Add this column here and divide this by total frequency. That gives us mean from a frequency distribution. Sometimes we have frequency distribution and we can also calculate the mean. Sometimes we have to calculate the weighted mean. So for calculating the weighted means, we have to multiply the data with its weight and divide it by the total weight. This can be useful for grade point average. For example, let's say A stands for 4, B means 3, C means 2, D means 1, F means 0. Let's say these are the corresponding weights for these grades. Then we need to calculate the grade points, compute the grade point average. So this is the example. For a student, C got A, B, C and F. So 2 A's, 1 B, 1 C and 1 F. We want to find out the grade point average, GPA. And for that, we have to multiply the grade with its corresponding weight, and then divide it by the total number of weights. That gives us 3.07 as a GPA. So in this case, we did not round it. The result is a first semester grade point average, which is 3.07. But instead of rounding it to the 1 decimal place, we just leave it to the 2 decimal place because of our common practice. Okay, so these are measures of centers. I'm going to show you some examples from the homework problem I have assigned for you. Section 3.1 homework, question number 1. A defunct website listed the average annual income for Florida as $35,031. What is the role of the term average in statistics? Should another term be used in place of average? So in statistics, instead of average, we use mean. So the term average is not used in statistics. The term mean should be used for result obtained by adding all of the sample values and dividing by the total number of the sample values. So D is the right option. Okay, let's go to next problem. Question number 2. In this problem, find mean, median, mode, mid-range for the data, then answer the given question. Listed below are the jersey number of 11 players randomly selected from the roster of a championship sports team. What do the results tell us? So we have given data. We can do this problem. We can find all these measures of center by manually doing the work, or just go here and click it and open this data in StatCrunch. You have to know the meaning of all these measures of center, but if your data set is very huge, then doing it manually is very time consuming. So we use StatCrunch. I'm going to show you how to do that. So first of all, go here, stat, go to the summary stat, click columns. So we would like to find out the summary stat for this column. The name of this column is VAR1, that means variable 1. So summary stat columns, select that column, and then when you go down here, that's where you can choose your statistics. What statistics you would like to find? We would like to find mean. You have to select after that median. To select the median, use control button on the keypad, control median, and then after that mode, control mode, and then after that mid-range. For finding the mid-range, there is no mid-range on StatCrunch, so we're going to find it manually, which is just a maximum plus minimum divided by 2. But for now, using the StatCrunch, if you just hit the compute button, it will give you mean, median, and mode, everything very quick. Okay, so let's go here and then use this value. Mean is 55.81. Type an integer or decimal rounded to 1 decimal place. So if you round it to the 1 decimal place, it would be 55.8. 55.8 is your answer. So check your answer. So that's how you plug your answer. And now next, go to the median. Median is 55. Check your answer, and then after that the mode is no mode, so there is no mode. So all these answer we can find them manually, or we can use the StatCrunch, and it's very easy. For finding the mid-range, you have to go back to the the data. When you click this column here, you can sort the data in ascending or descending order. If you sort it in ascending order, you can see that it's going from lower number to the higher number. So mid-range means it's a minimum value, which is 13, plus maximum value, which is 93, divided by 2. So if I use a calculator here, it's a 93 plus 13 divided by 2. So that's the mid-range, which is 53. 53 is the mid-range. Okay, what do the results tell us? Since this data is about the jersey number, so jersey number means it's a these measures, they don't tell you anything about the jersey number. So jersey numbers are nominal data, and they do not measure or count anything, so the resulting statistics are meaningless. So always after finding this this information, you have to go back to the real world situation, practical situation, and try to try to conclude your finding. So here, because this data represents a jersey number, this finding, it doesn't mean anything. Okay, so it happens sometime. So let's go to the next problem. Let's do number 5. One more time, the very same information, but this time this is foot length in inches of randomly selected women. So this is the height of the woman in a study of a country's military in 1988. Are the statistics representative of current population of all women in the country's military? So that's the question we would like to find, but let's first of all just open them in StatCrunch and find all this information. Go to the stat, summary stat column, choose the first one, find the mean and median and then mode and compute them. Put this value here. It's the mean is 9.54. You have to round it to the 2 decimal place. That's what they are asking us to do here. So round it to the 2 decimal place. It's a 9.54. 9.54. What is this? Listed below are foot length. It's not the height, actually it's the foot length. Okay, so this is the foot length, mean of the foot length. So check answer. Okay, the median is 9.8. 9.8. Round it to the type an integer or decimal, so that's the decimal. And mode is, what is the mode? 9.8 again. So mode is 9.8 inch. Mode means repetitive, most frequently repeated number. The mid-range, for finding the mid-range, you have to go back and sort your data in ascending order, and you have to find the mean of minimum value and then maximum value, which is 10.4 plus 8.7. You have to use calculator. It's a 10.4, which is the highest number, plus 8.7, which is the lowest number, and divided by 2. That gives us the mid-range 9.55. Type an integer or decimal, do not round it, so the answer is 9.55. Okay, after finding this information, we want to answer this question. Are the statistics representative of the current population of all women in the country military? Remember, this data is it's taken from back in 1988 from the country's military. So now can we use the same data to represent the current country military? So since the sample data does not include what is that? Since the sample is randomly and sample size is greater, since the sample is not a random sample, since the measurements were made in 1988, they are not necessarily representative of the current population of all women in the country's military. So this is the one of the right option, because it was taken long time back, so it might not be the right representation. Okay, let's go to the next problem, question number 10. A student course grade is based on one midterm that counts as 15% of his final grade, one class project that count as a 10% of his final grade, a set of homework assignments that count as a 30% of his final grade. Here we need to find out the weighted mean for finding the overall score. You can find out the weighted mean by multiplying the weight with the score. Remember, the weight is given in percentage, so you can always convert that percentage into decimal form. So we can use calculator here. 15% means it's actually 15 divided by 100. So that means it's a 0.15. That's the weight of midterm. So what is the score in midterm? The score is 65. So you have to find the product of the weight and then score. So 0.15 times 65. Okay. If you check your class notes, then you will be able to see the formula for weighted mean. The formula for weighted mean is summation of weight times the data divided by sum of all the weights. So that's the formula for the weighted mean. In this case, the data is your score, and we have given weight for different type of assignments. So in this case, like you can see here, there are different type of assignments, like midterm. The weight of midterm is 15%, so that is 0.15, and then a score in the midterm is 65. After that, there is a homework. Let's say homework. The weight of the homework is where is that? Weight of the homework is 30%, so that means 0.30. That's the 30%. The score in the homework is 75. And then there is a project. The weight of the project is 10%, so that means it's a 0.10. You don't have to write down that. 0.1 is fine. And then the score for the project is 81. Okay, and then finally the final exam weight is 45%, so that means 0.45. Then score in the final exam is 69. So to calculate the final score, you need to calculate this. Remember, if you change percentage into decimal, when you add all these weights, meaning if you add this column, which is summation of W, summation means add all this value in this column, that will be the one, because we are just adding all the percentage, and that's 100%, which is 1. Now to find the mean score or the final score, you need to find W times X. You have to multiply these two numbers, W times X, and then you have to add this column. So 65 times 15, 75 times 30, and things like that. So I'm going to use simple calculator here. 65 times 15, 0.15, it's 9.75, and then 75 times 30, it's what is that? It's 75 times 0.3, which is 22.5, and then 81 times 0.1, which is 8.1, and 69 times 45, 69 times, which is 0.45, 45%, it's a 31.05. If you add all this column, the value here, that will give you summation W times X, which is 9.75. So which is 9.75 plus 22.5 plus 8.1 plus 31.05. That's the final score, 71.4. Remember, because this sum is 1, so when you put this value back here, it's 71.4 divided by 1 is 71.4. So that's the final score, 71.4. That's the final score. And based on this grading criteria, 71.4 is C, right? So the letter grade is C.